This video is going to explain how to take a stratified random sample. Now, when I think of stratified sampling, I always think of the dinosaurs, and that's because when people dug into rock, what they found is that rock is arranged in layers, which are called strata. Strata is a name related to layers, and of course, in some of those layers, they found bits of dinosaurs. So, when I think of stratified random sample, there's a dinosaur bone. I think of layers. Now, data has layers, and it has all sorts of different layers. And which layers you take into account are really up to you, depending on what you're interested in. It's quite common to split data by gender. So you've got boys and girls. Or you could split it by age. If you split it by age, if you're in a school, for example, you might split it by year, so year 7, 8, 9, 10, 11, and so on. Now, just imagine we had a school, and we had a big pile of data, and we wanted to choose some data from it. Now, we could just say, well, we're going to pick 20 people at random from year 7, year 8, year 9, year 10, and 11, and that's our sample. And that would be a random sample if we picked them at random, but it might not be a very representative sample. So stratified sampling is all about being representative. We want our sample, and it must represent the population. There we go, population. So the population is all the data in our data set, the people in the school. The sample is a selection, and we want the sample to represent it. Now, we're going to look at an imaginary school where in year 7 we have 102 students. In year 8 we have 153 students. In year 9 we have 145 students. In year 10 we have 170 students. And in year 11 we have 60 students. Now, these are our strata, our layers, and we could do boys and girls as well, but we won't for this particular example. And if we want our sample to represent the population, the school, then we need to make sure that in our sample there are less year 11s, more year 10s, and so on. Now, first of all, we need to know how many people are in our school entirely. So that adds up 170 and 60, 145, 153 and 102, all add up to 630. So that's the total number of students in our imaginary school. Now, it's up to you to decide how big you want your sample to be. If it's too small, then it's not going to represent very well, because a small sample doesn't. You might just happen to pick, the shortest, or there's not enough people to give it a sort of fair chance of being representative. Too big and it's unhandleable. I'm going to go for a sample, for a 600, I'm going for a sample size of 30. So sample size of 30. And this is how I work out how many year 7s, 8s, 9s, 10s and 11s I need in my sample. I do it using simple fractions. So for the year 7s, I need the fraction, it's going to be 102 out of 630. So I need that fraction of 30. Year 8s, I need 153 out of 630 out of 30. And so on, 145 out of 630, 170, and finally the 60. I bet you're all just hoping that I've noticed that, aren't you? Whoa, that was a big eraser there. 170 out of 630, and then I'll just fix my 60. So, I use the actual numbers to work out a fraction, and then I do the fraction times the sample size. And you can use the fraction button on your calculator to do it. It's a perfectly reasonable thing. If you're doing this for a statistics piece of work that's related to real life, don't expect the numbers to be particularly nice. So I've got 4.9 for this one. And then I'm just editing on my calculator because that's the quickest thing to do. So I've got 153 now. And that gives me 7.3. And then I've got 145, which gives me 6.9, 170, that's 8.1, and finally I've got my 60. And that is 2.9. Now I've obviously had to round these, and I've got to pick a whole number of people. So that's going to round to 5 people. That's going to round to 7. That's going to round to 7. We've got 8, and here we've got 3. So let's just check it works out. 7 and 8 make 15. 15 and 5 make 20, 27, 30. Adds up to the correct sample size. So for my sample to be representative, and these are important words here, for it to be representative of the population with regard to this particular strata, the age, the year group of the people, then I need 5 of these, 7 year 8s, 7 year 9s, 8 year 10s, and 3 year 11s. Okay, we're going to finish off by having a look at what this looks like on an exam, because this turns up on statistics exams. It also turns up on the main GCSE exam potentially, so it's a useful piece of maths to have learned for several reasons. So here's an exam question. There's 4 marks for this. This would come towards the end of an exam, and it would attract a sort of A sort of grade bit of maths, but it's not very hard. So this is the population here. So this is the whole lot, 258 students, and it tells you what they study and the male, female. So we've got 2 directions, 2 strata here. We've got the language strata and the gender strata. Now, 258 students is obviously too many for what they're doing, so they're going to take a sample, and we have to work out the number of male students studying Spanish in the sample. So the answer is not 26, because this isn't in the sample. This is 26 in the population. But it's okay, it's really simple. So we need a fraction. It's 26, because that's the number of male students studying Spanish, out of 258. There's the fraction of the sample. And all we have to do is type that in. So it's 26 out of 258 multiplied by 50. And my calculator says that is 5.04, which means 5 male students. Work out the number of female students in the sample. So again, it's the number of female students in the sample, not here, this is the population. But how many female students are there? Well, we've got 48 and 62, so that is 110. So there's 135 female students in the population. So for the sample, it's 135 out of 258, and then the sample size on the end. So just editing on my calculator, because that's what anyone who has practiced will do. 135 over 258 times 50, and my calculator gives me 26.2, which is 26. There we are. And you can see that it's slightly over half, and that's because there's slightly more females than there are males. And that's stratified sampling. Hopefully you're looking at thinking, that's not too hard, I can do that. And just remember, the dinosaurs, strata are layers, and you can have layers in data, and if one layer is bigger than the others, then there should be more of that one in your sample. and if one is smaller, that part of the sample should also be smaller. And it's very, very simple. All you need to do is know the fraction, the sample size, and multiply them together. That's it. Hope this was helpful. Goodbye.